First, you got the chart okay?
Yeah, the chart was
What's this wanting you to find?
0.
Another word for that is, and the reason is you're zero high when you're a root, when you're an x-intercept. Okay? So, if they give you a polynomial in factored form, you can find it. What are the roots of p of x?
-5.
-5 and +1. By the way, I don't like writing this just because I'm worried I'll think that's the point, -5, comma 1. So I usually put a word and between them. I won't take marks off if you don't, but this is me really being paranoid, so when I look at my notes later, I don't misread it. What are the roots? What are the zeros for q of x?
-4.
Now, we called that a double root. It kisses right there. Ah. What are the roots for r of x? Now, what you're really saying is what makes that work out to 0 and what makes that work out to 0. What makes 2 take away x work out to 0? 2 take away what? Okay, so one of the roots is 2. What about when you had an x in the front all by itself? What would make an x work out to 0? It's so easy that it's a tough question. Yeah, 0 makes an x. This has roots of 0 and 2. If you have a polynomial in factored form, you should be able to glance at it and tell the roots. And a lot more. Oh, by the way, what else? If you have a polynomial in factored form, is there a negative right there, Mackenzie? Caught you mid-yawn. Is there a negative right there? This opens up. Is there a negative right there? This opens up. Oh, wait a minute. I take that back. If you FOILed this out, can you see that you would go like that? You'd have an x times a negative x. What's an x times a negative x? What's x times x? Can you say that shorter instead of saying x to the power of 2? We have another little short way to say that. X squared. So what's x times negative x? There is actually a negative here. This opens down. This opens up. This opens up. I can tell you that. I can tell you the roots. I could already give you a fairly good sketch. Is that okay? Any other questions from the homework? Yep. 8 and 9. Love to. Someone else wanted you to ask and they were too embarrassed, so thank you. Are you about to put your hand? Okay. So, Alyssa, this is an attention span, first of all. Okay. This is how well we can generalize. By the way, today's lesson is going to be pretty long. Mondays will be much shorter. But I want to get all of today's lesson done if I can. You know what? Let's generalize. Parabola opening down. Parabola opening down, and the constant term is going to be negative. Here, the constant term, the y-intercept, is going to be positive. Parabola opening up, y-intercept positive. Parabola opening up, y-intercept negative. Lines. Okay. Graph the number corresponding to, and they're going to give me a generic pattern. First of all, look at the x, Alyssa. Squared or not? Sorry, nice and loud. So it's one of these. Okay, now, here's what they said. A and B are bigger than 0. That's a fancy way of saying they're both positive. You know what kind of an equation they're talking about? This. There's an example of A and B being positive. I just made it up. Or this. Or what? All I know is, what's that going to look like? Line or curve? Line. Positive or negative slope? So that's wrong and that's wrong. I'm not going to cross those out permanently. Positive y-intercept or negative y-intercept? What graph best corresponds to this condition? Graph number what? Okay. Now, what I don't like about this question is the dumb way they're having you answer. I would never have you do some kind of weird numerical answer. I would make this a multiple choice or a fill in the, or put the blanks next to them or something like that. Okay. Oh, Here, both A and B are negative. Here's an example. Y equal A has to be negative, less than 0, negative 2x minus 5. I know it's not a parabola, so I'm not even going to scroll up. I'm not even going to show the curves. Which graph best matches that? Graph 5, 6, 7, or 8? Okay. Then here we have A and C. Look up. A and C are positive, so it's going to open up, and it's going to have a positive y-intercept. Which one opens up and has the positive y-intercept? That one. Yes? So a 3. Both negative, so it's going to open down, and it's going to have a negative y-intercept. You know what? Got to be that one. I hope the answer is 5, 8, 3, 2. I don't know. I don't like the way that they ask for, like, to me, filling in the numbers like that at the end that's a contrived numerical question. What I would do is I would almost certainly make this some kind of a matching thing. Okay? And again, you notice I didn't do this abstractedly. As soon as they gave me the conditions, I made up examples because I'm much more comfortable with that. And as soon as I saw that, I said, oh, it's got a negative slope, but it's negative x, y-intercept. It's that. Is that okay? 9, same idea. I'll let you try number 9 on your own. Now, this is going to be a bit tougher. Here, they're saying A is negative, but B is positive. So downhill slope, positive y-intercept. Okay? And this is the short way we write the words negative and positive in math, because writing the word negative and positive is too much work. Less than 0 or bigger than 0. That's the very different definition of negative or positive. Okay, I'll let you try that, and you can ask me that next class if you're still stuck. Any others? So if, oh yes, Julia.
Number 5A.
5A?
Just the range part.
Okay. What kind of a graph is this? Is it a parabola?
No.
Is it a linear?
No.
Is it a constant? You know what the range is? This is a graph. If you drew it, it would look like that. You know what its range is? Just that's the only height that appears. Its range is the constant term, is its height. Nature of turning point, there ain't one. End behavior, it's a constant little, nothing changes there. Is that okay?
No, about the first one, it was ones after that.
Oh, the ones after that.
Yeah.
For the range?
Yes.
What kind of a graph is this?
Linear.
Positive or negative slope?
Positive.
It's going to look like that. Range is all reals, except pretend that gap in the middle didn't appear. My pen lifted off the screen. There, sorry. Trickier, this one. Okay? Now, last year you learned how to do it by hand. We are using, it does say use a graphing calculator, so here's what I would do. Menu, graph, 5 minus x squared. When in doubt, I usually use the standard view window, graph. What's the range? Everything below that. What's that? It's the maximum. Everything below and touching 5. That's how fast you can do it. This is why I said we're going to be using our graphing calculators a lot. We're going to get it. So the range would be y's, range, below. I know it touches because we played with the parabola last year, 5. Okay? So just try graphing them, and you can find the vertex by either using maximum or minimum, and the y coordinate will be the range portion. Is that all right? And Bree, you had a question? 3? Okay. Degree 1 means linear graphs. Look up, Brianna. We're talking those graphs or those graphs. What's the domain of either of those? It's the same. All reals, all reals. What's the range of either of those? It's the same. All reals, all reals. How many x-intercepts will they have? Well, remember, x-intercepts are where you cross the x-axis. How many times does each of these cross that blue line? How many times does this cross the blue line? They have the same number of x-intercepts. In fact, what's the degree? What's the degree? How many x-intercepts? What's the degree? 1. How many x-intercepts? Not a coincidence. How many y-intercepts? Well, if I add another... don't! The eraser didn't vanish on me. Let me try that again. If I had a y-axis, how many times are they crossing the y-axis? Once. That's also the same. Okay? For parabola, I'll let you think about it, but we're talking about this kind of a parabola and this kind of a parabola. I don't think they're all the same. I think domain will be. Range, depends on whether it opens up or down, so no. Number of x-intercepts could be 2, or could be 1, or could be none. So, no. I think they have the same number of y-intercepts. Okay? I'd love to talk more, but could you please turn to page 341? Thank you, please. Next lesson. And you absolutely want your graphing calculator handy. We're going to be graphing lots like crazy. Okay? So right now, get out your graphing calculator, turn on the graph mode, and right away clear any graphs and go to View Window Standard. Get that set up because we're going to start there and then probably have to muck around. Anybody who don't have their graphing calculator here, tell me. I'll borrow a phone and I'll swap, but it's important. Good, by the way, what we're also trying to do with the practice is you're getting fast so that it doesn't bog you down on the test, because I'm going to be expecting you to be able to be almost as fast as me up here on a test. When I write my test for this, I'm going to be budgeting that much time for each question. Anybody not have their calculator here? We're all good? Okay. A cubic function is an x cubed, degree 3. Quartic is an x to the 4th, quintic is an x to the 5th. We're not going to get that high tech. But a cubic function is a polynomial of degree 3. Here are 2. We're not going to graph these by hand because we don't need our phones or anything because we're not that important. We're going to graph these by hand. No, sorry, we're not going to graph these on a graphing calculator. If you did, though, here's what you would see. What do they have in common? What don't they have in common?
They only have one y-intercept each.
Okay. First of all, I would say this. They are slightly slanty-ish. Slightly slanty-ish. Almost as though they have a positive slope. Now, I can't call it a slope, Oscar, because it's a curve. But can I use kind of the same idea? Hey, what do you think a negative in front of the x cubed would do? I told you, we're trying to generalize everything that you've learned about graphs. Turns out a negative is going to have it slant downwards. I can't call it a slope because it's curvy. Okay? Now, every cubic function then is either going to be going like this or it's going to be going like that. What will its domain be? All reals. What will its range be? All reals. How many x-intercepts will... we're going to come to that. How many y-intercepts will it have? 1. How many x-intercepts? All right. What's the degree? What's the most number of x-intercepts it can have? But you're not guaranteed. How many does this have? Count with me. 1?
2, 3.
How many does this one have?
1.
Okay. Or if I took this graph and I moved it up higher, maybe B might be sitting right there. It wouldn't dip down long enough to give you the next 2 intercepts. But you're always going to be guaranteed of at least 1 if you're doing that. You got to cross the y-axis somewhere if your domain is all real. The x-axis somewhere if your domain is all. If your range is all reals. You got to cross the x-axis. You got to have a root somewhere if your range is all reals. But you might have the most 3. You might have 2. You might have 1. You won't have none. They have some similar end behavior. They kind of shoot off at kind of like a line. But in between, they have different characteristics. So here's some terminology. P of x has 2 turning points, A and B. A is a maximum because it's the highest. In calculus, we would say A is a local maximum because the graph does go higher over off to the side there. And if you talk to any of your friends that are in calculus, they spent an entire unit learning how to find by hand local maximums and local minimums. You can do it using calculus. It's one of the things Sir Isaac Newton invented. We're going to use technology. B would be a minimum. Is it the absolute minimum? No, it goes lower right there. But in its area, locally, it's a minimum. They're turning points. So there's a maximum turning point because the graph changes from increasing to decreasing. There's a minimum turning point because you're going from decreasing to increasing. A and B are not the overall maximum or minimum. The range is all reals. But the math word we use is locally, they're a maximum or minimum. And your graphing calculator can find those. Q doesn't have any complete turning points. Are we going uphill? Are we going uphill? Are we going uphill? Are we ever going downhill? We're going uphill. It, for a split second, leveled off, but it didn't dip down. We call that, and here's a word you're going to use, an inflection point or a point of inflection. These would be, if I give you a chart, good questions to have you fill in the blanks on a chart, similar to the one, Julia, that you asked me about the homework that had all the domain. I can give you lots of graphs and chart questions here, and you're going to use technology. But, next page. What else? Consider the following cubed functions written in expanded form and in fully factored form. First of all, how do you factor an x cubed? There is a way to do it by hand. Your graphing calculator, I don't think, has it built in, but put your pencils down. I'm going to show you how. So Wolfram Alpha, great site. Put your phones face down, put them away. Yes, I'm talking to you. Thank you. It says this, graph each function on a calculator using, okay, first of all, let's change our view window. So I'm going to go delete whatever graph I have. Remember, when they give you a view window, this is xmin, xmax scale, ymin, ymax scale. So let's do that. Shift view window, xmin, -2, xmax for scale 1, ymin, -5, 7, scale 1. Exit. Now, let's type in equation number 1. X to the power of 3 minus 3x squared plus x plus 5. And that's about how fast you want to get. And once you have it, graph it. How many roots? How many roots? 1. If this here was lower, if it was right there, I would get the second and the third root. But right now, 1. You're guaranteed for x cubed, you always have 1. It says sketch all 3 graphs on the grid. So, because I have colors, I'm going to do this first one in blue. And what's it look like? First of all, G solve, root. Okay, so it goes right through there. I can actually put a dot there. What's the Y-intercept? You don't need to find it mathematically. Look up, look up. What's the shortcut? What's the Y-intercept? The constant term. 1, 2, 3. I know it's going to go through there. What's this? No, root would be where it crosses the x-axis. What's this right here? Begins the letter M. It's a minimum? Oh, G solve, min. Apparently, okay, that's a yucky point. I'm not going to graph that. But if that had worked out evenly, I would have tried to get it in the right place. 1.8, comma 2.9. I'll kind of eyeball it. 1.8, 2 kind of about there. So it looks kind of sort of like that. Yes? Those are the what I'm interested in getting right, Laura, are roots, intercepts, and max mins. Let's graph the next one. Exit. Hey, look up. Don't delete this equation. If you did, that's fine, but look up. I'm going to toggle this one off, deselect it by hitting F1, go down arrow, because I might need it later, I don't know. And I'll type this second one in Y2. That'll also help me keep it organized. Second one in Y2 makes sense to me. X cubed minus 3x squared plus 4. Draw. Uh-oh. Did I type this in right, Mr. Dueck? I missed an X. Let's try that again. Minus 3x squared. Brandon, you raised a great point. What did you say? Okay. In fact, what we used to teach our kids in Math 12 was when they hit graph, they would move on to the next question on the provincial exam, start it, and then they would come back to this one. And they got good at just jumping back and forth. My suggestion for you, once you hit graph in your homework, see if you can move to the next question and start setting it up. Sorry, it's what I got. Hey, what are the roots? Oh, I can tell you the roots both by going root, -1 and 2. Can you see the roots and the factors? Okay, so if you have the factored form, you really don't need to use the technology. So this goes through, I'm going to do this one in red. There and there. What's the Y-intercept? What's the Y-intercept? 4. 1, 2, 3, there. So it looks like it does kind of I don't know if the Y-intercept is the highest point or... Well, wait a minute. Max. Oh, the Y-intercept is the highest point. It's a max. G-solve. Min. Oh, there you go. I'll do the third one in black. By the way, how many roots will this one have? Look up. How many roots will this one have? I'm going to make a prediction. There's going to be a root at -1, +1, and 3. Now, look up. The only way that works is if, when you guys graph it, it should end up looking... That's the only way I can, without lifting my pencil, give you 3 roots. Does it look like that? I'm going to delete mine so I can be more accurate. Exit, you know what? I'll toggle this one off. Deselect. X cubed minus 3x squared minus x plus 3. Minus x plus 3. Draw. Oh, hey, I was right. That's exactly the shape I predicted. Grayson, what's the Y-intercept going to be? Look up. It's right in the equation. It's always going to be the constant term. 3, right? So 1, 2, 3. I'll put a big dot there, 2. You want to be really accurate? I could get you the maximum, which is there. I could get you the minimum, which is there. Okay. Anyways, it looks kinda, sorta, like that. Pardon me? It will. Let me pause. What are at least 3 characteristics that at least 5 things that these graphs have in common? Well, all 3 of them? How many Y-intercepts? 1 Y-intercept. What else? Sorry? They have? All 3 of these do, but I can't guarantee that for every single cubed. I love the way you phrased that. It's impossible for them to have none. Why? Because they all have the same range. All reals. So Y-E-R. They all have the same domain. X, E, R. And they all kind of slope up. I'll just do that. What are two things that are different? Number of roots. Right? What else? Now, we contrived these very carefully, but I would certainly say the value of the y-intercept. Now, the y-intercept is the easiest one to change. You just change the constant term. You want a y-intercept of 9, x cubed plus blah, blah, plus blah, plus 9. That'll give you a y-intercept of 9. You want a y-intercept of negative 10, x cubed blah, 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 minus 10. That'll give you the constant term. The other stuff, a little more complicated. How can the number of x-intercepts be determined from the fully factored form? How many x-intercepts did this have? How many x-intercepts did this have? How many x-intercepts did this have? How can the number of x-intercepts be determined from the fully factored form? Really, it's the number of brackets, but not quite. I'm not going to write that down because they phrased this a little sloppily, I think. How can the value, so the value is find the zeros of each factor. What the heck do I mean by that? For example, if you have a factor of x plus 7, what's its 0? What would make that bracket work out to 0? This is why we also call them zeros, by the way. The root of that, the x-intercept of that would be negative 7. What if you had an x plus 6? You'd have a x-intercept, a root, a 0 of negative 6. Who remembers the nastier ones? What if you had 2x minus 5? Remember how to do those? Positive 5 over 2. It was change the sign of the constant term, divide by the coefficient. I'm not going to freak because you have technology anyways. Let's keep going. Turn the page. So it says, in each case, we're going to be doing lots of very, very quick graphing here. So you got your graphing calculator out? Hey, Brianna, first thing we're going to do is we're going to change our view window. So, you ready? Delete all the graphs that you have. I guess we're not going to reuse them. Change the view window. So x min, negative 8. Psst. X max 8. This time we're going to go up with a scale of 2s. Down arrow. Y min, negative 20. Y max, positive 20. Scale 5. Everybody okay with that? Exit. All right, the first one, x cubed. What do you think this will look like? Looks like this. It doesn't quite give me the max min curvy bump. It's got an inflection point, as a matter of fact. It looks like I used to give these a nickname. What's the degree of x cubed? 3. The number 3, is it an odd number or an even number?
Odd.
So the x cubed graph belongs to odd numbered, odd degree functions. And I used to tell my kids that these were John Travolta functions. Ready? Because John Travolta is very odd. That's how we remembered it. Odd degree functions are John Travolta functions. Or if they're negative, okay. By the way, what's the domain? What's the range? Make sure you don't get x and y mixed up, a number of you did on your test. How many x-intercepts? Just one. Right there. How many y-intercepts? Also just one. By the way, what's the constant term in this graph? What's being added right there? It's invisible. Plus what? Don't say plus 1. That would not be invisible. Plus 0. That's why the y-intercept is 0. How many turning points? None. There's an inflection point, but does it ever go downhill? No. In other words, if you try going G-solve max, you're going to get an error. There isn't one. Left tail goes that way. Right tail goes that way. All right? It slants off and it slants off. Is that okay, Rach? Good. Same graph. Oh, you know what? What do you think that negative in front should do? Sure would be. In fact, it will. It's going to go like this. Try graphing it if you want. I got too many graphs open. Close this one. Negative x cubed. Draw. Is that okay, Brandon? Or what's your question? Have you already started doing it in the head? Okay. Hey, what's the domain of this? Still, all reals. All reals. How many x-intercepts? 1. How many y-intercept? 1. 0, comma 0, as a matter of fact. How many turning points? Isn't 1. Oh, left tail this way and this way. Yep. Well, okay, if you want it as a point, sure, 0, 0. I wasn't sure. They didn't. You're right. They didn't say the number of y-intercepts. They just said, what is the y-intercept? Good catch. F, third one. Now I have no, oh, wait a minute. I know one thing. Before we even graph, look at this third one. What's the y-intercept? 0, comma, negative 20. Let's go see what this looks like. I need to move this over so I can see the graph. 2x cubed minus 15x squared plus 33x minus 20. Oh. Okay. Like this. Let's exaggerate that a bit. Okay, what's the domain? Okay. Hopefully that's getting a little redundant. What's the range? How many x-intercepts are there? 3. Ooh, how many turning points are there? Giancarlo? 2. 1 there. And 1 there. And you know what? Does that. Increasing, whatever you want to say. Okay. Now, let me zoom into this one here. Look at this equation. Before we even graph, here's what we know already. What's the y-intercept of this equation here? Huh? 0. I can fill that in. 0, comma 0. Hey, what's the left tail and right tail behavior? It's going to be that way and that way. Right? Because negative. I'll give you one more. Look up. Is there an x in everything? That means if I did factor, I'd factor an x to the front. Who remembers when you had an x in the front of the brackets, what was the root? One of my x-intercepts is going to be a 0. All right, now let's graph it. Oh, I got to move over. Okay, and I hope you're practicing typing these in. You want to get fast. So -4. And if you're having trouble typing these in, make sure you shoot your hand up and let me know, and I'll come help you. But if you don't say anything, I'm assuming you're getting the same graph we are. This is also the time for you to make your typos and figure out what you're doing wrong. Right? I got that. I got this. Got a root there and a kiss there. Am I right? Is that what you guys got?
Mm-hmm.
Yep. What's the domain? All reals. What's the range? All reals. The more interesting part, how many x-intercepts does this one have? 2. How many turning points does this one have? 2. Where are they? I got one there. Well, right at the x-intercept. I should have figured that out. And one there at 0.6667. By the way, do you really think that's 0.66666667? Or probably what is that value actually? Probably 2/3. If you wanted an exact value. You kind of learn to spot some of these. Oh, and we already predicted left tail, right tail. Hey. Look up. See this graph? See this equation. How are they the same? How are they different?
What is the constant term of -6?
Otherwise, they're identical. All we've done is we've taken this graph and we've moved it 6 down. I'm telling you, don't write this down yet, but it's going to look something like that because we moved it 6. Well, that's a little sloppy. It's going to look something like this. We moved it 6 down. I betcha. Let's find out. Now, since it's almost the same, go up arrow on Y1 and just go to the very, very end instead of retyping everything. And just add the takeaway 6. Told you. So Darian, now you're starting to kind of know this number, the constant term, doesn't give the graph its shape. It gives it its height. These are what give it its, negative tells you which way it's slantying. And these coefficients give you the bends. Domain. All reals. Range. All reals. How many x-intercepts this time? Just 1. How many y-intercept? Oh, sorry, not how many. Where is it? 0, -6. Still 2 turning points. Still doing that and that. Hey, this next graph also looks identical, but instead of being moved 6 down, how has it been moved? 2 up. So if you can imagine this graph here moved 2 up, kind of to there. Hey, how many roots are you going to have now? You see it? See it 3? Okay, I got to bring this back. And so now this is how we play around and make these equations look the way we want to look. If I go here, exit, +2. Told you. This goes through there. Domain, all reals. Range, all reals. How many x-intercepts? 3. Y-intercept, 0, 2. I got sloppy here in this drawing, Mr. Dueck. Let's try that again. Should go through. like that, 0, comma 2 up there, not through 0, 0. Turning points, 2 of them, and it still does that and that. A couple more. Is it 3 more? We're good? Yep. Okay. Before we graph this next one, what can we say? What's the y-intercept? I can tell you that. Oh, what's the domain? All reals. What's the range? Is this graph going to go this way, uphill, or is this graph going to go this way, downhill? It's going to go uphill, so I can tell you the left and right tail behavior, because it's positive. The other two things, how many x-intercepts and the number of turning points, that's where for some heavy-duty algebra and some calculus comes in. So now we're going to graph it. Again, I see a number of you just kind of watching. You want to get good at typing these in. Oh. Kind of like that. How many x-intercepts? Didn't see that coming. How many turning points? Didn't see that coming. No turning points. So on this graph, if you tried finding a maximum or a minimum, can you get an error? Yeah. Next one. Before we even graph, what's the y-intercept? 0, comma 14. Before we even graph, what's the domain? How about the range? Is this graph going to be going downhill or uphill? Because it's got a negative in front of the x cubed. The leading coefficient is negative. All right, the rest I got a graph to figure out. Negative 4x cubed plus 22x squared minus 32x plus 14. Draw. Oh, nice. I got a double root. I got a kiss right there. So it looks like it's going to be and now I can answer the rest. 2 x-intercepts, 2 turning points. Is that okay? You guys got the hang of this, or we didn't do the last one? Pam's yawning, so let's move on. What was that, Taylor? Nothing's new? Oh, okay. Is it a tricky one? Oh. Ah! You know what? Let's do the last one because Giancarlo said something weird happens. You're right. I should have trusted that they would have something interesting at the end here. 2x cubed plus 10x squared plus 6x. Take away 5. I don't think you need to adjust the view window. I think you did something wrong. You will sometimes need to adjust the view window, but I don't think we're going to go there yet. So let's just turn the page. Yeah, that'll do it. Amrit, what can we generalize on? All together now, everybody. So for every cubic, all together, what's the domain? Everyone. Guys with me? For every cubic, what's the range altogether? Really, people? And for every cubic, how many y-intercepts? 1, and it's going to be the constant term. And if there is no constant term, it's a 0. What did you notice about the number of turning points? Every x cubed either has blank or blank turning points. You either got none or 2. And the reason is, if you just had 1, now you're a parabola because you can't turn back. I have to turn, if I want to get that shape, I've got to turn, I got to have 2. And how many x-intercepts? What were the possibilities? 3 or 2 or 1. Could you ever have none? Not if you've got a range of all reals. You're going to cross the x-axis somewhere. But you could have 3, 2, or not, or 1. The end behavior is determined by the leading coefficient. Insert the word up or down. If the leading coefficient is positive, the right tail goes and the left tail goes up. Well, I guess I'll call it down. You know what? I don't like up or down. Here's what I like. The right tail goes like this. The left tail goes like that. Quick look at money. Negative, left tail, right tail. They come downhill. Here's your quadrants. If the graph, it says, starts in quadrant 3 and ends in quadrant 1. Sorry, let's try that again, Mr. Dueck. If the graph starts in quadrant 3 and ends in quadrant 1, the leading coefficient is positive or negative? Positive. If we start in quadrant 2 and end in quadrant 4, we are negative. It says, circle the correct alternative. The end behavior of a cubic is similar to the end behavior of a, kind of, as it goes further out, it looks more and more like a line. In the middle, it's got the wavy bumps. Hey, what was the degree of a linear function? Do you remember? 1. What's the degree of a cubic? 3. Are these both odd numbers? They're both John Travolta functions. Very odd or very odd. Nearly done. Okay. Little thought experiment. Yep. Nope. Almost done. Psst. I know I've talked a lot, but you'll have more time to work on this on Monday. But I want to get this all percolating. So look up. Okay. A student graphed this, but here's what the calculator said. How do they know this has to be wrong? Jake. So not only do they, in fact, where did they probably make their mistake? What are they almost certainly missing? The x to the power of what? They've almost certainly made an x cubed mistake. So you can now, if you know you're getting the wrong answer, go hunting for where you made your typo. Okay? So that's an x squared parabola, a quadratic, not an x cubed. I think it was Bree, and I did it myself. You know what? They probably forgot to put the x in front of the squared for the x squared, and then you get weird stuff. Or the x in front of the cubed. Okay? So, here is our lovely summary. We now have constant, don't write this down, degree 1 linear, degree 2 quadratic, degree 3 x cubed. Here's what I would write down. This is the stuff you want to have at your fingertips. What's your homework? Number 1 is good. Again, Alyssa, these are similar to the, okay, it's saying which of these could be x cubed graphs? Okay? Number 1. Number 2, do a sketch with those particular characteristics. Number 3, true, false. I'll skip 4. 5 is good. 6 is good.